The main challenge in on-policy distillation is prefix failure, where early mistakes derail the entire training process. On-policy distillation is a powerful technique for transferring reasoning capabilities from large teacher models to smaller student models. By letting the student generate its own trajectories, we avoid the distribution shift common in offline training. However, this approach has a major flaw. If the student makes a mistake early in a long reasoning chain, it continues down that wrong path. The student wastes valuable compute generating long, incorrect sequences, and the resulting training data becomes highly unreliable. Prefix failure occurs because standard distillation forces the teacher to supervise highly derailed, incorrect student paths. When a student model commits to an incorrect reasoning direction, all subsequent tokens build on this initial deviation. In standard on-policy distillation, the teacher is forced to provide token-level supervision on these completely derailed paths. This is highly inefficient. As shown in Figure 1, instead of letting the student generate a long, incorrect continuation, we need a way to intervene early, correct the reasoning, and get the student back on track. The core breakthrough of this work is identifying a teacher-student continuation asymmetry on failed prefixes. On a failed prefix, a strong teacher model naturally wants to stop, re-examine, and redirect using reflection tokens like but or wait. Meanwhile, the weaker student model blindly presses forward along the wrong path. By monitoring this divergence, the researchers created a label-free handoff trigger. We don't need external verifiers or reward models. The disagreement on whether to reflect tells us exactly when the student has failed. Relay-OPD solves prefix failure by dynamically handing control to the teacher at detected failure points. As the student rolls out its trajectory, the system monitors each prefix. When a handoff trigger fires, the teacher briefly takes over to generate a short teacher leg that steers the reasoning back to a correct path. Control is then handed back to the student to resume generation. To prevent the trajectory from drifting too far from the student's own policy, a strict relay budget caps the number and length of these teacher interventions. To avoid massive computational overhead, Relay-OPD is implemented within a single speculative decoding engine. Running two separate models and constantly switching control between them would normally introduce massive scheduling and communication overhead. To solve this, Relay-OPD unifies the entire generation process into a single speculative decoding engine. The student serves as the draft model, and the teacher serves as the target model. During student legs, drafts are accepted unconditionally. During teacher legs, standard speculative rejection sampling is used. Relay-OPD delivers superior reasoning accuracy while cutting training trajectory lengths in half. Across 8 mathematical reasoning benchmarks, Relay-OPD consistently achieved the best or second-best results, outperforming standard OPD by over 5.7% on a 1.7 billion parameter student. Remarkably, because the teacher intervenes early to stop runaway incorrect generations, the average training trajectory length was cut by over 50%. This means the model learns much faster while using half the compute. While highly effective, Relay-OPD's current design relies on domain-specific reflection tokens and a strong teacher-student capability gap. First, the current implementation relies on a predefined set of mathematical reflection tokens, meaning the trigger set must be adapted for other domains like code generation or agentic tools. Second, the method assumes a capable teacher that can reliably redirect failed prefixes. As the gap between student and teacher narrows, the benefits may decrease. Nonetheless, this framework opens up exciting new avenues for highly efficient, state-driven model alignment.